Da 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 da. Da, 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 da. It is almost time for me to go home. You don't get the points for that one unless you can actually name the movie that it was in. True story, in the 1990s, Kristen Gilbert was a nurse. She was doing very well. Some of her coworkers noticed that she seemed to have some patients who died, perhaps more patients than typical. Other people said, come on, don't get after the nurses. Sometimes a patient dies, they're doing the best they can. But someone said, let's actually look at the data of how many people died compared to Kristen Gilbert and other nurses. So Kristen had 40 patients who died under her watch. That's sad, but most of her patients lived, 217. Now, for other people, they had patients die too. Is Kristen's proportion so much more that we're going to say she's an angel of death? Now, I hope you've noticed the wording that I've used is which nurse the patient has independent of whether they died or survived. This looks like it could be a chi-squared test or it could be a two-sample proportions test. We're going to do it both ways and figure out which one is better. Let's start with what we've done before, the two-sample proportions test. We're going to test whether Kristen's proportion is equivalent to what the other nurse's proportion is for patients who died. The alternative being that there's something different about Kristen Gilbert. We'll set our alpha to 0.05. It turns out it's not going to matter. Our z-score is the difference in the two proportions. Notice here I have that pooled proportion, the 74 out of 1641, and I get a z-score of 9.29. I'll bet you're familiar enough with the z-table that you know 9.29, that's 9 standard deviations out there, way off the chart. P-value is basically 0. We reject. Kristen's proportion is not the same. Would we get the same answer with a chi-squared test? Well, that's going to look like this. Notice we've got the null is that the chance of death does not depend on which nurse you have. That's saying the proportions are equal. Or that the chance of death does depend on whether Kristen is your nurse. That's the proportions not being equal. We have here our expected values in chi-squared. Notice the number of patients who survived with other nurses, exactly what we would expect, but the number of patients who died with Kristen, that number is a little high. Our chi-squared is going to have 1 degree of freedom. We add those up, we get 86.48. If you go into the applet and put that in for your chi-squared, it's going to be way off the chart, which gives you a p-value of 0. So which one is better? They are actually the same thing. If you take 9.29 and square it, you'll get this. What am I trying to emphasize here? We're doing statistics with the same data, 2 different methods. You'll get the same answer either way. And some of the homeworks are meant to emphasize that specifically. You could choose which method you like the best. This one is going to be reject, and the proportion is not consistent for Kristen. Same thing. They took this data to Kristen Gilbert and said, you got a p-value of 0, and it's way out there. Something wrong and weird is going on. She eventually did confess that she had a little crush on the police investigator guy that would come. That relationship did not work out. Here's what I want you to remember from this lesson. You get the same answer if you have a 2x2 table, whether you do 2 proportions or a chi-squared test. The z-score is going to be the chi-squared if you square it. That's kind of where the name chi-squared came from. In this case, the p-value is 0, but even if it wasn't 0, you would get the exact same p-value from either method, and you'll see that in some of the homework questions, which is really cool. You can pick which one you like the best.